Wow, I really enjoyed learning in Labs 1 through Lab 12 and creating an autonomous car that didn't burn out our motors. Yeah, that was super fun, especially in Lab 5. I just wish we had a little more control over our car. It's alright, self-driving cars are the future anyway. Yeah, but we've already turned in our project proposal, and it's a week until the due date. So I mean, we don't have time to make anything else but a car. I just don't see the problems with our car. Well, first off, the car we currently have requires bumping into a surface a bunch of times, which seems to dislodge the automation system. Secondly, our automation system isn't even that reliable. It doesn't trigger sometimes. Honestly, there has to be a better way to do this. Well, we could just add an emergency stop button in controls. Nah, we can just have the car stop autonomously. Wait, but I thought the whole point of our car was to... okay, fine, let's just do it your way. So, like we'd stated previously, the lever action switches were a good start to building a car, but we found through repeated tests that the whole system was prone to failure after a couple of runs due to the nature of the circuit, and that the lever action switches tended to just snap off the frame of the car after a couple of runs. So, to alleviate this problem, we added human controls through the flex sensor and an H-bridge, since us humans would actually have more awareness of the car's surroundings than itself, since, of course, the car's awareness of its surroundings would simply just be what the lever action switches are touching. Aside from that, since humans, of course, are also prone to failure, we added an emergency stop, which was characterized through an ultrasonic rangefinder mounted on the front of the car and an Arduino, which could process that signal. So that's what you're going to see in this video, is the ultrasonic rangefinder reading a distance smaller than 10 centimeters, which is going to cut off the enable voltage to our H-bridge. So in this video, it's obvious that only one of the wheels is working, and that's due to the resource limitation we were currently experiencing, which was later resolved, of course. But obviously, this first wheel works, so we figured the second wheel will work in the same way, and it did. To wrap this up, one of our primary motivations was to create a mechanically sound car and a mechanically stable car. So while we succeeded in the aforementioned aspects that we'd thought about, such as reducing the amount of moving parts, we failed to recognize the vulnerabilities that our new system would create, specifically the flex sensors. And so during our demo, one of the soldered connections to the flex sensors actually snapped off, and we ended up with an extremely faulty car because one of the wheels kept running. So in retrospect, we actually removed a moving part and just added a different moving part. So in retrospect, obviously there's a different way we could have done this. Maybe we could have made it more stable instead of simply just adding a soldered connection. Maybe we could have taped over it a little more. But of course, hindsight is 20/20. There's no way to go back on that. And so, of course, huge thanks to our TAs, to Professor Schmitz, and of course to the lab groups around us that really helped us through the different problems we were having. This concludes our video, so thank you for watching, and I hope you have a fantastic day.